So I would like to introduce the next speaker. The session is Shell Synthetic Edge, would be delivered by Mr. Ahmet Guven. So Ahmet Guven is the global product application specialist. He has 30 plus years of experience in the areas of lubrication. He is specialized in steel and cement industry and within lubrication in hydraulics. Academically, he is a chemical engineer with MS degree. He travels and supports the business in Europe and Asia. He is based out of Istanbul in Turkey. Over to you, Ahmet.
Welcome. My name is Ahmet Guven, as you mentioned. I'll try to explain you the synthetics. While I was trying to make this presentation, I think I canceled many of the slides to make the things more simple for you and to make them more rememberable for you. What happened? I did nothing. Okay. So this is the agenda. I'll try to explain you the base oils. What are the base oils? And can you see no, you can't see it. Okay. I will try to explain first the base oils itself, then the types of base oil groups. We'll try to understand what are the mineral base oils. We'll try to understand what are the synthetic base oils. Then, as all the presenters try to explain you, I will also try to explain you why we need synthetics, what are the advantages of synthetics, and how we protect the bearings. As the friend from Timken has underlined, lubricant has a significant role for protecting the bearings, and oxidation stability in examples, polyalpha-olefins, and energy efficiency. Well, what is lubricant? Lubricant is any element that is reducing the friction. Friction is very important. If two parts are moving on each other, there is friction. Solid friction, if we take the coefficient of friction of solid to solid is 1, when we have lubricant, the friction can go down to 0.01. That means that we are reducing the friction 1,000 times. We are moving solid friction to lubricant, fluid friction. That is the importance of lubrication. My friend from Timken, while he was explaining, I was listening to him very carefully to learn new things, he said that they have a new coating. And the coating, maybe you didn't catch, I catch very easily because I know the issue. The coating, he said, started from the PIMS. Huh? Why? What is the reason why they start from the PIMS? Because they do not move. When they do not move, then you don't have lubrication. Lubrication starts when the two parts are moving on each other. When they are moving, the lubricant forms a film and separates them from each other and changes the solid-to-solid friction to fluid-film friction. That's why they start from the PIMS. If you are in the mining sector, you know that most of the time the excavators and etc. fails, most of them, from the PIMS because they don't move. When they don't move, there's no lubrication. Lubrication is so important to reduce the friction. When you reduce the friction, you increase the life of the bearing. We all know that lubricants are made of two things: base oils and additives. Why additives are there? Additives are there not to lubricate. Additives are there to improve the quality of the base oil. Lubrication is 90%, 95% done by the base oil. There is only special regimes that we can have additives lubricating the system. That's called the boundary lubrication, where the film thickness is so thin that parts are touching each other. In that case, the additives get into reaction. We call them extreme pressure additives. They are there to react with steel to reduce the friction. Is it desirable? People think that when you have EP, you are protected. Yes and no. Yes, when they touch each other, there is friction. When there is friction, there is heat. When there is heat, this EP additive reacts with the steel and changes the coefficient of friction. What does this tell you? This tells you that this EP additive is very reactive. It is in action. When it sees heat, when it faces with heat, it's going to react with metal, or it's going to react with the molecules in the base oil, or it's going to react with the seal material. So, while you are choosing additives, be careful, do you need EP additives? If you need EP additives, you have to choose the right fluid, because there are EP additives that are very effective, but very harmful for the system. Sorry. While we are making the base oils, as I said to you before, 80 to 90% sometimes is formed from the base oils, the lubricants, depending on the application. It can go down to 80, it can go up to 98%. So if we know the base oil quality, if we understand the base oil quality, we can understand how the oil is behaving in the bearing, and we can also influence the quality of the lubrication. So base oil has a very significant importance in lubrication. Now, we have 3 different types of base oils. The first one is the mineral base oil. 90% of the lubricants are made from mineral base oils. The second one is our subject, synthetic base oils. They are more or less 10%. Why? They are very expensive, and you have to justify to use them. And we have also natural base oils that we are not using anymore. We are using them sometimes because of their biodegradable property. How we manufacture base oils? We manufacture base oils, especially mineral base, how we manufacture mineral base oils, excuse me, I have to correct myself. How we manufacture mineral base oils? We manufacture mineral base oils from the crude oil by refining them. We have different refining processes, different know-hows and etc. Mainly, they are, one is called the solvent extraction, then we have the hydrogenation process that we are trying to saturate the double bonds. And depending on the process, this base oil quality changes. There is also one very important factor, which is the crude oil, which is really important. You can buy crude oil from Libya, you can buy crude oil from North Sea, and you can buy crude oil from Middle East. All these have very different properties. If you buy crude oil from Libya, you are also buying a lot of waxes inside. That base oil has to be extracted from the waxes too much. How much you try, at least you might have some waxes inside. So the base oil quality itself is very important. Sorry, the crude oil quality is very important for the base oil performance. In the base oil, we have different molecules, different types of molecules and structures. 2 days ago, we were coming from a steel plant, and in my mind, I was trying to make these slides. How can I tell people that base oil is formed different of molecules and etc.? Because most of you are not chemists. And when I check the traffic, I find that it's like the base oils. We have the motorcycles driving, Hero Hondas. The word Hero Honda is, I think, it's my interpretation, for Honda is the cycle and Hero is the driver. He is risking his life in this very risky traffic. That's my interpretation, by the way. But Hero Hondas are coming. We have trucks. We have cars. In a base oil, the same thing is happening. We have different types of molecules. And these molecules have carbons from 20 to 50 carbons, mainly, chains. And on the other hand, they have a molecular weight of, sorry, I am blocking my presentation. They have, let's say, molecular weight of 350 to 550 in molecular weight. And we have paraffins, naphthans, which means double bonds, and we have aromatics, which have the benzene ring. I'll come to more details in that one. This is my interpretation for before that one. It was my interpretation with the balls. I should use the motorcycles and the trucks. Anyhow, but this is how the base oils are. The first, this one is the normal paraffins. They are saturated. They are very rare. These are the isoparaffins, which means they are branched. Most of the paraffins are based like this. They are very reluctant to get reaction. We call them saturated ones. And these are the naphthenics. Although we say paraffinic base oils, in group 1, the concentration of these naphthenics can go up to 20 to 25 to 30%. Please bear in mind why I am saying this one, because these naphthenics, if you don't extract them properly, are very susceptible to oxidation. When there is high temperature, they can get into reaction. When they can oxidize, when they are oxidized, they are going to produce acids. They are going to produce varnish and sludge, which we do not want. Why? They can clog the lubricating lines. Varnish can hinder the heat transfer, and varnish in the long term can block the valves, can move, have sluggish movement with the valves. We have aromatics, which are susceptible to oxidation. These are two different molecules, which are sulfurs. These are sulfides. They are good, by the way. They are natural antioxidants. And there is a debate going on that we are just extracting too much of them, that we are also, let's say, harming their natural antioxidancy. For example, for group 2, that's a problem. And we have the mercaptans, which are susceptible, responsible of that very bad smell. You don't feel them with the base oils, but when you have the diesel, the motorin, the gas oil, whatever you call, the bad smell is coming from these mercaptans. And they are very open to oxidation. I already explained all these things, but just to give you more things, that these are naphthenic base oils. They are very susceptible to oxidation, but they are very good for solvency. They dissolve the additives inside, and these are aromatics that we don't want, and they are very open to oxidation. This is the famous base oils classification. You might know it, you didn't heard it, but you have to know it if you get into this business. We have 5 groups. Group 1 is the base oils that we have saturates less than 90%. What do we mean by saturates? I mean the paraffins. You remember that they are all only branched or not, having 3 carbon atoms. They are saturated. They are like the men who fed themselves. They don't want to get into reaction. If you ask them, let's eat something, they are cool guys. They say, okay, I am here. I don't want to do anything. So even the temperature goes up, they don't want to get into reaction. But these ones, the unsaturated, they get into reaction. And in group 2, we try to eliminate them, so the saturated ones are over 90%. That means that group 2 is better than group 1 in oxidation stability. Sulfur is also another defining factor, which is going down below 0.3% in group 2. Group 3, although you see it is very close to group 2, in fact, this classification is not explaining it very well. In group 3, what we are doing is, in the refinery, we are trying to tailor by chopping them, by saturating